right, so this is Virtual Environmental Education with Lane Tech Sustainability Club. This is Lesson 2, Ocean Acidification. I am the not vice president, I'm the co-president, Anna.
I'm Amanda, an environmental volunteer.
I'm also an environmental volunteer. My name is Emily.
And my name is Joseph, and I'm also one of the co-presidents of Sustainability Club.
All right.
So the definition of ocean acidification. According to Calderia and Wickett, ocean acidification is the ongoing decrease in the pH of the Earth's ocean, caused by the uptake of carbon dioxide, also known as CO2, from the atmosphere. But let's find out what more of this means.
What is ocean acidification? Ocean acidification is when carbon dioxide is absorbed by seawater. Chemical reactions occur that reduce the pH and carbonate ion concentration of salt water. Carbon dioxide is a greenhouse gas in the atmosphere that traps heat. It's a fossil fuel that is released from cars, factories, airplanes, and many other energy-using facilities. Calcium carbonate minerals are the building blocks for the skeletons and shells of many marine organisms. Reducing the pH of salt water makes it more acidic. For example, we can compare this to us drinking a glass of water. Since we are used to its pH, no harm is done to us. However, when we drink a glass of lava, which is something we of course don't drink, it can kill us since it is acidic and has a very low pH that our bodies are not used to. The reduction in carbonate ion concentration does not allow underwater organisms to develop strong skeletons. And without calcium carbonate, many organisms aren't able to build their own shell.
So here's a picture of the process of ocean acidification. So as you can see, there's a factory on top of some land, and the factory pollutes CO2, as shown. So then the CO2 is then absorbed by the ocean, and about 30% of it is absorbed into the ocean, and the CO2 mixed with the water makes carbonic acid. This carbonic acid is then broken down into bicarbonate and hydrogen ions, and the presence of hydrogen ions is what makes the ocean more acidic. These free hydrogen ions, though, bind to more carbonates, which are the things that the organisms need to build their shells, and makes bicarbonate, which is acidic and causes the ocean's pH to decrease.
So more on ocean acidification. Since the Industrial Revolution, the ocean has absorbed about 30% of the world's CO2 emissions. And the Industrial Revolution was when people started to make new technology and new machines to make tasks a lot easier. And the ocean is a carbon sink, which means that it slows down global warming because CO2 can be used by photosynthesis using organisms in the ocean, but the amount currently being released into the ocean is unsustainable and can lead to more damage to the ocean. And the amount released is unsustainable because the more CO2 that enters the ocean, the lower the pH levels drop, which means the ocean becomes even more acidic, and that can kill organisms in the ocean. And marine organisms that don't have calcium carbonate shells or skeletons need to spend more energy to regulate their bodily functions in acidic waters. And this is because the calcium carbonate shells and skeletons protect organisms from predators as well as shelters them from the environment.
Carbon cycle. The carbon cycle is the biogeochemical cycle, which is a pathway an element moves through different processes of the earth, such as water moving through the water cycle as it goes into the air and freezes. The carbon cycle is when carbon is exchanged among the different spheres of the earth. So it can go through air, water, or land. Carbon is important because it helps regulate the Earth's temperature and helps plants get the energy they need by helping them produce glucose through photosynthesis. So plants don't eat other organisms, so they need to make their own energy, and they do this through glucose. And carbon helps keep the planet warm. But if there's too much carbon, then the planet can go into extreme increases of temperature. So the planet needs to be warm enough for organisms to survive, but it cannot be too hot that the planet goes into an extreme global warming, because that changes the global temperature and that causes climate change.
So on Earth, most of the carbon is stored in rocks and sediments. And so places where carbon is stored are known as carbon sinks. So rocks and sediments of the Earth are carbon sinks, while the rest of the is located in the ocean, atmosphere, and living organisms. Carbon is released back into the atmosphere when organisms die, volcanoes erupt, fires blaze, fossil fuels are burned, and in many other ways. This is because they release energy in the form of materials that they are made up of. So for example, the energy that they're releasing is carbon dioxide, which is made of carbon. In the case of the ocean, carbon is continually exchanged between the ocean's surface water, which is the top of the water, and as you can see at the beach, the waves, and the air surrounding it, which is called the atmosphere. But CO2 can also be stored deep within the ocean, and as seen in the ocean acidic picture that we showed in a couple slides ago, the CO2 was reaching deep levels of the water. So this is a picture of the carbon cycle, and it shows how carbon from the atmosphere is then brought down into where like humans would live, which is where like the plants and trees are. And then it's also brought into the ocean, and it's shown that it's on the surface of the ocean, it's in the middle, it's at the deep, it's at the bottom in the sediments, and then it continues up. And then there's also CO2 being polluted from factories or farming or cars and other, producers of CO2, and that's all brought back into the atmosphere. And this just keeps going in a continuous loop.
Acidification. Ocean acidification is mainly caused by carbon dioxide gas in the atmosphere dissolving into the ocean. This leads to a lower pH of the ocean, which means it is more acidic. And again, we can compare this to us drinking water and not being harmed by its pH, but when we drink lava, we die due to its low pH and acidity levels, and this is the same as the acidity in the ocean killing the marine animals. pH is measured on a scale of 1 to 14, and the lower the pH number, the more acidic the substance is. Here we have a picture of ocean acidification. And so let's look at number 1. Here we can see carbon dioxide from the atmosphere dissolving into the ocean. This then causes a chemical reaction, and the dissolved CO2 and the water build up into carbonic acids, and these then results in many more dangerous molecules. And if we look at the top right corner, it shows that the lighter blue is less acidic and the darker blue is more acidic. Looking back at the picture, we can see in the lighter area of the ocean, which is less acidic, the shells are not deformed. But if we look at the darker area of the ocean, which is more acidic, the shells are deformed.
Calcification is when the mineral calcium builds up in the tissues of an organism and causes the soft tissue to harden. And our bones are also made up of calcium, and that's a form of calcification. And similar to that, organisms need to protect their structure, so they calcify to make a skeleton or a shell. And calcification is how organisms with shells, such as coral, oysters, and crabs, and other organisms as well, are able to build their own shells. And ocean acidification makes calcification more difficult by making the seawater more acidic, and by decreasing the pH level of the water, carbonate ions decrease in abundancy, which basically means that there aren't enough carbonate calcium ions to build the shells of calcifying organisms, and carbonate calcium ions are what make up the shells.
Ocean acidification and mass extinction events. So the Cretaceous Paleogene die-off, the mass extinction event that killed off the dinosaurs after a meteor hit the Earth, killed about 75% of living species on the planet. And many of the deaths were organisms in the ocean, such as calcifiers. Recent evidence from Yale scientists has shown that marine calcifiers were killed off in a higher abundance than most of other organisms. And it is suggested that the increase in ocean acidity made calcification virtually impossible, which led to their deaths. So they weren't able to make their own shells, which means that they didn't have the ability to survive in their environment anymore.
So ocean acidification and more mass extinction events are that many organisms that use calcification are at the lower levels of the food chain. And so the death of the calcifying organisms results in the death of organisms that eat them because they lose their food source. So for example, at the bottom of the food chain, you might have some crabs and lobsters, and then the bigger fish or the bigger organisms like sharks or something will eat those crabs. But if they're not there, they can't eat them, so they will die too. And then the next level of the food chain will die in addition to that, which just causes the mass extinction to happen because all the organisms die, since the lowest level of the food chain died first. And so there are more organisms, though, at the lower levels of the food chain and less predators at the top, just because of how it works. And that with using photosynthesis, the first level of the food chain is able to be in more of abundance, whereas bigger organisms have to fight each other off for food sources. And then also, in addition to this, quick pH changes in the water can be too fast or make it impossible for some organisms to adapt to, and it can cause those organisms to die. So if the pH in the ocean drops from 8 to 3, the fish that lived at an 8 pH might be used to maybe a 7 pH or a 9 pH, but when it dropped down to 3, it was too harsh for them to live and they just died instead.
Impacts of ocean acidification. Ocean acidification impacts the fishing and shellfish industries. Higher acidity levels cause the deaths of fish that cannot survive pH changes outside of a certain range. And again, we can compare this to the water and lava analogy, and it's because these organisms are not used to these acidity levels. And decreasing levels of calcification kills off shellfish, which decreases revenue for shellfish industries. And calcification protects the shellfish, and they cannot survive without their shells or skeletons.
So some more impacts of ocean acidification. Coral reefs are bleaching because of the higher ocean acidities and rising sea temperatures. And the corals are releasing the algae that lives in their shells, and without the algae, the corals are highly vulnerable and lose the majority of their energy. And the algae provides stability and movement for the corals. And scientists believe it's possible that corals will become extinct by the end of the 21st century if carbon emissions aren't reduced. And marine organisms are the planet's largest source of natural sulfur emissions, which decrease the amount of solar energy that can reach the Earth. And with less sulfur, global warming will accelerate. And sulfur protects the Earth by cooling it, and it's not a greenhouse gas, so it doesn't go into the atmosphere and increase the temperature.
So what needs to be done to stop ocean acidification? Well, according to the Inter-Academy panel, they stated that by 2050, global CO2 emissions need to be reduced by 50% at least. And if we could at least reduce them to even more than that, that would be even better for the environment. The global temperature also needs to not increase by more than 2 degrees Celsius, which is about 36 degrees Fahrenheit from the pre-industrial global temperature level.
What can we do to stop ocean acidification? Well, there's so many things that we can do. Well, the first thing is that we can team up with groups who are against ocean acidification. So shellfish industries are losing money because the shellfish are dying due to them losing the ability to make their own shells, and so they lose revenue. Island nations, they have coral reefs that surround the islands that protect the island from predators such as sharks. And as the coral reefs die, they lose an ecosystem because fish that they fish for food source around the island are living in the ecosystem that the coral create, and they can't live there anymore. And so the sharks are able to attack them and they die. And not only are they losing access to the water, but as the water acidifies more, it's becoming unsafe to swim in it. And these island nations, they survive on tourism. So people come to the islands to swim. And if they can't swim in the water, they don't see the point in coming anymore. So they lose a lot of revenue from that. Also, youth who want a future. So students such as you guys who are watching this, you guys want to learn more about climate change, what you can do to make a difference. It's important that you guys join the movement to help stop ocean acidification if you want the oceans to be clean so you guys can swim in it later on in your life. And so species that you know and love don't go extinct sometime in your lifetime. Renewable energy companies. So renewable energy companies such as windmill companies or solar panel companies. Solar panels receive energy from the sun, and wind turbines, which are windmills, they receive energy from kinetic energy, which is a movement of the wind. And they are against climate change because there's a way to get energy without using resources that are non-renewable, resources that we cannot replace, and that's what their companies are all about. And then also the climate change movement. So this club is part of the climate change movement. We're against climate change. Our focus is to educate people about climate change and make it a very relevant topic in society. And all these different groups want to make people more aware about what's going on. So some ways that we can help stop ocean acidification is we can eat less meat. Meat production uses a lot of fossil fuels, and fossil fuels such as CO2 get released into the atmosphere, and CO2 causes ocean acidification. We can also use less energy at home. Not all energy used in our homes are going to be renewable. So by using non-renewable energy, we're releasing carbon dioxide into the atmosphere because fossil fuels have CO2 in them, and that contributes to ocean acidification as well. We can also reduce plastic consumption because producing plastic requires a lot of fossil fuels such as CO2, and also plastic bags can't be recycled easily, along with a lot of other plastic, and a lot of that plastic actually ends up in the middle of the Pacific Ocean on this island called the Pacific Garbage Patch. And the Pacific Garbage Patch isn't an island you want to go to. It's an island that is completely made of garbage, and lots of sea animals get stuck in the garbage and die every year getting caught in the aftermath. And that's just horrible for the animals and for their ecosystems because it literally ruins their ecosystems. We also want to conserve water because it is not an unlimited resource. A lot of water is contaminated and wasted, and we want to ensure that water is not being wasted. We also can buy less material items such as fast fashion. So if you buy a t-shirt you know you're not going to wear in a year, you probably shouldn't be buying that shirt because one, it takes a lot of energy to produce it. It takes a lot of water. It takes a lot of CO2, and that all contributes to ocean acidification. And the last thing that we can do is you can bike or walk as much as possible, because when you're driving, you're releasing fossil fuels into the atmosphere. Cars use gas, and gas has CO2 in it, and that, as we know, is the major contributor to ocean acidification as well as climate change. So one way that you can figure out how much of all these different things that you're doing is you can calculate your carbon footprint, and in the follow-up email after this video, we will send you guys information about how to do that, and you can learn how you can reduce your impact.
Okay, so ocean acidification around the world. Ocean acidification is affecting the entire ocean, and around the world it impacts island nations the most because island nations rely on coral reefs to shelter the island from predators, but they also use the coral reefs for food because fish live in the ecosystem that the reefs create.
Ocean acidification and sustainability. Being a part of the teams that rise up to fight climate change is a way to be sustainable in the fight against ocean acidification. Ocean acidification and climate change go hand in hand because the oceans are the largest carbon sinks on the planet, and when they aren't able to take up any more CO2, the rate of climate change will rapidly increase. One more thing about ocean acidification is that it is one of the most significant environmental issues today, and it is causing great harm to marine life. As a sustainability club, we believe in improving the quality of human life and the life of other organisms on the planet while taking care of the environment at the same time.
All right, so this is the end of our presentation.